All right. So we're going to be looking at exponential functions in this unit. Okay, so everything's going to change. Your graph is going to change. Your equation's going to change. Your table's going to change. Okay, we're still going to be moving at a constant rate, but we're no longer adding or subtracting with an exponential. Okay, it's going to go faster. Okay, an exponential function is a function in the form of f of x. Remember, f of x is just function notation. It means the same thing as y. So my equation now is f of x equals a times b raised to the x. Exponential. We're looking at exponents. Okay. So a is now going to be your initial value. B is your base or your multiplier. And x is your exponent. Okay, so some things you need to remember with these. A cannot equal 0. Why do you think A cannot equal 0?
Because it's 0.
Pretty much, because it's 0. Look, you've got A times B. Well, what happens if I make A 0?
Oh,
It's going to be 0 no matter what. So if A is 0, my answer is always 0. Okay, there's no way to move it if A is 0. So A can never be 0. Okay, it's usually 1 unless we transform it. Okay, so your A value is usually 1. B cannot be equal to 1. Because what's 1 raised to an exponent?
Itself.
Itself. It's 1. Okay, so whether I take 1 and I raise it to the second, my answer is 1. If I take 1 and raise it to the 7, my answer is still 1. So B can never be equal to 1 because it will never change. Okay? No. No, that's a good question though.
B is known as the base.
B is known as your base. So B is known as the base. Okay, and just like a linear, your y-intercept is also known as an initial value. Because when x is 0, we get my y-intercept. Okay, so if we actually go back to some exponent rules, anything that I raise to the 0, so I can raise 14 to the 0 power, and my answer is 1. I can raise x to the 0, and my answer is 1. Because x would be x to the first power. It's x. Anything raised to the 0 power is 1. Okay? I can raise -2 to the 0 power, and my answer is 1. I can raise xyz to the 0 power, and my answer is 1.
So 7 billion to the 0 power is 1.
Yes. 17 million raised to the 0 power is 1. That is an exponent rule. Okay. So anything to the 0 power is 1. Okay. We're going to look at these. Okay. Oh, I always have trouble spelling this out. Hold on. I'll look it up. I spell this wrong every stinking time.
Asymptote?
Yes.
A-S-Y-M.
A-S-T-O-P.
There we go.
A-T-O-T-E.
A-S-I-M-T-O-P-P.
There we go. I do. I spell it wrong every time.
Asymptote.
Asymptom.
Okay.
That's like a pill that you would take for depression.
Okay. An asymptote is an imaginary line that the curve of the function approaches but never crosses. Okay. So we're going to look at this when we actually look at graphs so you can see what this looks like. Okay. Right now we're just trying to get some vocabulary in here. I don't know.
Maybe if you broke that down, they probably had.
There's probably some kind of.
something that deals with that. I don't know.
What's your question? Right in the middle of no. French.
She said she'll do it for me.
No. Okay. Exponential functions. Just like linear, your exponential either increases or decreases. Okay. The B value is also known as the growth factor or the decay factor. Okay. So growth would mean that my line is increasing. Decay would mean that my line is decreasing. It's dying off. Okay, so you actually deal with these more in science class. Okay, when you talk about the growth of cells, the growth of bacteria, the decay of bacteria.
Yeah, I know.
Okay.
Snails eat the glue.
You said thought it's smelling?
No, snails eat
Oh,
poop.
snails.
Snails eat poop and they decay.
Snails eat poop and they decay.
Yeah.
Fun fact of the day: snails eat poop and they decay.
Yeah.
Okay. So it says if my B value is somewhere between 0 and 1, we have what we call a decay. Okay. So we're looking at something like 1/2, 1/4, a fraction that is between 0 and 1. Notice my B value will never ever be negative. Does not become negative. Okay. If it's greater than 1, 1.5, 14.
It's a growth factor.
It's a growth factor. It's getting bigger. Yes, it can be 1.5. It just can never be negative 1.5. Yes. No. I just got done telling everybody else no. All right. So flip it over. Let's look at this algebraically. Open it up, flip it over, whatever. You know, one of those things. Okay, so this is what your equations are now going to look like. Okay, 3 times 1/2 raised to the x.
It's a decay factor.
Okay, so yes, this is decay. Why?
Because the B is in between 0 and B.
Okay, so TJ says my base, which is what is being raised to the x. So my base is 1/2 or 0.5. Oops. Shrunk it too much. Okay, my base is 1/2 or 0.5, which means I have decay.
The initial value is 3.
My initial value is 3. Okay, so what this is saying to you is you start with like 3 things. And every time it's being cut in half. It's decaying by 0.5. So it would go from 3, cut in half would be 1.5. Okay, cut in half is actually 0.75. Okay. $1.50 cut in half is 75 cents. Okay, so it's decaying by half every time, and we start at 3. Take a look at this second one. I start at -2, and my base every time I'm increasing by 5. So is this growth or decay? This is growth. This time I'm multiplying by a 5. So it's blowing up or getting bigger.
So when it's growth, that means that -2 will go to like -1. Or does your initial value will always increase?
Yes. So you're basically looking at this number to tell whether it's growth or not. So because this number is bigger than 1, that tells you it's growth. Because this number is less than 1, it's decay. So your base is telling you what's happening.
So if your base is more than 1?
It's always growth. So even if it's like 1.1, it's still growth. It's still bigger than 1.
So what if it's just 1?
If it's just 1,
It can be a negative, right?
it should never be a negative number. It's either going to be between 0 and 1, or it's going to be bigger than 1.
more chance of it being growth.
All right? Let's take a look at what this looks like as a table. Okay, so my table says -2, we have 0.5. -1, we have 1. 0, we have 2. 1, we have 4. 2, we have 8. What is my initial value?
-2.
No. My initial value is 2.
2. What?
How do you know that?
I don't.
It's increasing by 2, right?
That has nothing to do with it.
Because the y is always 0. The x, I mean.
Your initial value is your y-intercept. When we're at my y-intercept, that means my x value is 0. So 0, 2 makes my initial value 2. This is my y-intercept. Okay.
It's a growth. No, like, yes, it is. It's a growth.
Okay. I agree it's a growth. And Brenda, what did you say before? Where did you come up with 2? It's multiplying by 2 as I go up. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So my base is 2, which means that this is growth. So this tells you right here the difference between a linear table and an exponential table. Linear, I was adding 2 each time.
Oh.
Exponential, I'm multiplying by 2 each time. So that's the difference between a linear and an exponential. Your lost how, Seth? You can't just tell me you're lost. You need to tell me where you're lost and what I need to talk about. Because I'm lost does not help me. How do I got what? Because I'm multiplying by 2 each time, which means my base is bigger than 1, which makes it a 2, which makes it growth. Anytime my base or what I'm multiplying by is bigger than 1, we always have growth. So because my pattern along my y's is multiplied by 2, that's my base. which means that that is growth. So your actual equation that goes with this table is 2 times 2 to the x. This is your equation. As soon as we finish this one, I will let you run to the restroom before we get into the next one. Okay, so that's your equation. My A value, my initial value is a 2. My B value, what I'm multiplying by each time, is a 2 raised to the x. Okay, flip it over. What does this look like as a graph? Here's your graph. Okay. Because it's a curve, you can't call it a right angle. Okay, so remember, we read graphs starting at the left and going to the right.
Left to right.
So if I go from the left and I'm going to my right, what is happening? I'm decreasing. It's getting smaller as I read my graph from left to right. So this is decay. What's my initial value? 2. Good.
It's 2.
It's my y-intercept, which is 2.
Horizontal asymptote.
Okay.
What is that again?
I'm about to just circle.
Take a look at my graph.
Oh.
Okay. So my graph's coming down, coming down, coming down. And then here it kind of levels off. It's leveling off at what we call a horizontal asymptote.
But the line is touching.
So it is, but it's not. So it looks, because it gets so small, this graph comes down and it levels off. Whoops, that is not leveling off, that's going up. Okay, so your graph's kind of coming down and it's leveling off. So it's going to keep getting smaller and smaller, but what it doesn't do is it will never touch this horizontal asymptote.
That's what it looks like.
Okay, it does look like it's going to touch, but that's because it's such a tiny fraction. So like a point clear out here could be like 1/264. Okay, so it's so small that you really can't tell the difference. But just know that there is something called a horizontal asymptote. What does my horizontal equation look like? Is it y equals or x equals?
X equals 0. Wait, are you asking for me?
I want a horizontal asymptote.
X.
That is one.
It's y.
Oh.
Your horizontal line is y equals.
I thought a vertical line. Oh.
No, sweetheart.
What equals what?
So y equals, what number does it look like it's leveling off at?
No, 10. Wait.
On your y, it is y equals.
-2.
-2 is clear down here. Is it leveling off at -2?
-1.
-1 is here.
No. 1.
Whoa.
0. 0. Fast off. 0.
3.
It is leveling off
8.
here. What y value is this?
-0.2.
0.
0.
I said 0.
Oh.
I'm trying to figure out why I'm getting answers of -2.
I said 0.
Okay? -2 is clear down here. My line's not even close to -2. So it's leveling off at y equals 0. So what is my range then? Is my graph above 0 or below 0?
Oh.
Above. So y is greater than 0 because my graph is above 0. So it has to be y values that are greater than 0. No. Have you not just heard me tell 6 other people? No. Okay. Take a look at this one. Okay. What is my initial value here, even though it doesn't ask for it?
1.
It should be 1. Your initial value is 1. Is this growth or decay? It's not going down. You read from left to right. So as I go from left to right, it's getting bigger. So this is growth.
So if it was, that was on the other side, it'd be decay.
Yes. So if it would look like this, where it starts high and comes down low, it's decay. Because it starts low and goes high, it's going to be growth. Okay. Where does it look like my horizontal asymptote needs to be here? Where does my graph level off at?
I want to say
1.2.
no, like -3.
-3.
-6.
Okay. It's leveling off around -3. So y equals -3 is my asymptote. And you would draw it in here. Okay, so take a look at your picture. Is it above -3 or is it below -3? Above. So my range is y is greater than -3. Yes, quickly. Miss AL. Miss AL, quickly. Didn't you have to go to the bathroom? I thought you had. TJ, quickly. I can send one boy and one girl. Oh, wait, never mind. Andrew asked before you. I lied. Andrew, quickly. My bad, I forgot. Okay, while the rest of you are waiting, that page glues in on page 70. Okay, once you glue that in, I want you to quickly plot these 3 points and draw your exponential graph. On your next piece, I need you to plot those 3 points and draw your graph.
School on 69?
Your title page should have been on 69.
60, doing on 70?
Yes.
said we don't put it in. We don't keep it in. Wait, so we skip the page and do that? Oh.
I drew in your graph, so.
You didn't have to rush me about that. This is good. No,
That looks hard. They're hard to graph. Because you can't really use a roller for it because it kind of goes neat.
I like this group.
You like this group? Why? Because they're quiet and you can focus.
You say you got an ugly laugh.
It'll be better when your friend comes back. Whoa. All right. So let's talk about this. What's one thing you can tell me about this graph? It is curved, so that makes it exponential. It's growth. Okay, so this is growth. So that should be up in this top left corner. This is growth. Yes. Your base tells you if it's growth or not. Okay. So this is growth. What else do you know about this?
The initial is 2.
Your initial value is 2. So that's your y-intercept. The bottom left-hand corner is your y-intercept. It's 2. Okay? So this is also your initial value. Asymptote? Okay, so Xavier just said my horizontal asymptote is at 0. He is absolutely correct. It levels off here. So that's my horizontal asymptote at 0. And that is top right flat. So my asymptote is at y equals 0. Okay. So, okay, because we now know our horizontal asymptote, you can tell me what the range is. So, should my range be greater than 0 or less than 0? Greater than 0. It's above. Okay. Can anybody figure out what my growth factor is? Remember, it has to be multiplied. Multiplied by what? By 3. It's going 2 to 6 to 18. 2 times 3 is 6. 6 times 3 is 18. So, my growth factor is a 3. So, I have a base of 3. Okay? Because my y's are going from 2 to 6 to 18. So that's times 3. 6 to 18 is times 3. So that's my growth factor. Good.
So yeah, always multiply when it's exponential.
Yes, exponential is always multiplication. Okay, so some things that we need to talk about yet. An exponent. Your exponent is x. And this is usually time, whether it be in months or years or days. Okay, it could be centuries. Okay. What, the flaps? I did. You really don't have to. It doesn't matter to me. It's up to you. Okay, so we know what our range is. What we haven't talked about yet is domain. Okay, you said what?
Domain. Range of domain.
Domain is my x's.
And the range of domain.
So how far is my graph going to the left?
6, -7, 7.
Just because that's what's on my graph does not mean we've stopped.
Infinity.
It's going from negative infinity, and it's going to grow and grow and grow and grow and grow. It's a positive infinity. So an exponential. An exponential equation, your domain should always be all real numbers. Unless they tell you there is a restriction on your domain, your answer should always be all real numbers. The one that's going to change is your range. Okay? It could be above your horizontal asymptote or it could be below. So you have to find that asymptote first before you can do the range. Okay? Okay, the last thing we're going to talk about is something called end behavior. Okay? End behavior is telling me what is happening to your y's as x approaches something. So, we said, as I go to the left, my x is approaching negative infinity. So, we say, as x approaches negative infinity, y is approaching what?
Activity also.
It's going way down and down and down, because that's what you just told me. You told me that as x approaches negative infinity, my y value is approaching negative infinity.
No,
It's not what it's doing. As x approaches negative infinity, what's my y doing?
Curving.
Curving? Where? What is this line?
The asymptote.
The asymptote, which was what?
Two.
0.
Oh.
So, as x is approaching negative infinity, my graph is leveling off at 0. So, y approaches 0. Okay, so if you're reading it and however your x is going, if it's starting to level off, it will approach that asymptote no matter what. Okay, so we can also look at the other way. As x approaches positive infinity, y is approaching what? So as x is approaching positive infinity, so I'm going to keep going to the right, keep going to the right, keep going to the right. What's my y doing?
It's approaching the sign.
It's approaching what?
The sign. Going up.
It's going up. Is it ever going to stop going up?
No.
No. So your y value is also approaching infinity. Okay, so it's kind of another way to look at your range is your end behaviors. Okay, y is never going to go below 0 because your range is y is greater than 0. So it's never going to go below 0. So that's where this came from. It will approach 0, but it will never go below 0. Okay, your domain is all real numbers. Your range is getting bigger. It's going bigger than 0. So that's why y approaches negative infinity. Okay, we'll talk a little bit more about end behavior as we go through. End behavior is not usually a big topic in Math 1. You will talk a lot more of end behavior when you get into Math 3. So I'm kind of introducing it. We'll talk about it as we go. Okay, questions? Yes. 2 problems. 2.
About this?
Okay, so your homework tonight. I'm going to pass this out. The instructions are on there. Okay, technically 6. So listen, it tells you right over here what you're doing. It says, cut out all pieces, glue down the title, make 2 columns in your notebook. So this will be on page 72.
Like how we did.
Okay, so make 2 columns. One is growth and one is decay. Analyze each exponential representation. Tell me if it's growth or decay. Glue in each function where it belongs. Leave some space to write. With each one, I need you to give me the initial value, and I need you to draw on each graph the horizontal asymptote and write its equation. Where it levels off.
And you write the dotted lines.
Yep. Okay, you can highlight it if you prefer. That's fine. Okay. So while you have scissors and glue, because you have 15 minutes, I would at least cut these all out and glue them in where they belong. Yes. That last piece we just finished will glue in on 71. This will glue in on 72.